start complete chapter 5. Okay. Last time we studied the formation of esters, which is a condensation product between the carboxylic acid and an alcohol. Okay, first, again, take a look at the functional groups of these two types of molecules. Carboxylic acid is what? CO carbonyl group with the OH. Alcohol is what? OH, hydroxy group. Okay, the condensation means what? Means we're taking a water molecule. That's why we call this reaction a type of condensation. We're taking a water molecule. And the water molecule, again, is H and OH. The OH is from the acid, always the acid. Remember, they both have OHs, but for this reaction, the OH is taken from the acid, and the hydrogen is taken from the alcohol. Then you're making a bond between the carbonyl C and what? And the O of the alcohol. So we get a new functional group, COOR. Okay, COOR, and we call this an ester group. And this new bond between the C and O is what? Is the ester bond. Okay, it's the ester bond. Again, this is the scheme like we did last time to help you better understand how do we make an ester bond. And you guys also did this practice. Okay, did this practice. Now, like at the very end of the previous lecture, I mentioned to you that not only we're going to make an ester, know how to form an ester bond, but also when you're given a structure, you can recognize the molecule is an ester by identifying the functional group we just mentioned. COO what? R. Okay, again, the R must be a carbon. Okay, that means the R must be a carbon group. Okay, when you see this functional group COOR, you know this molecule is a what? Is an ester. And after you find out it's an ester, you need to look for the ester bond. The bond between what? Between the C and what? And the O. The single bond between the C and the O. And this bond, single bond, is what? Is the ester bond. Okay, it's the ester bond. Now, after you find the ester bond, okay, like we also practiced by the end, is you put your finger or pen on the ester bond because that's the new ester bond. And that bond is linking what? Two-part molecules together, right? We know ester is between what? An acid and an alcohol. This is the bond linking what? An acid and alcohol. So when you put your pen here, you have to recognize which part of the molecule is from the acid, which part is from what? From the alcohol. The one that came from the acid should have what? Carbonyl group. Okay, again, never left or right, because it depends on how the molecule is drawn. All you need to recognize which part has what? The carbonyl. If it has carbonyl, then the molecule is from what? From the acid. And then the other part contains the OR is what? From the alcohol. Does it make sense? Okay, now, after this, you know this part is from the acid, this part is from the alcohol. You actually can write what the acid is and what the alcohol, or I should say what the acid was and what the alcohol was, based on how we did the reaction. Remember, when we get the bond, we first did what? Remove the OH from what? The acid. Is that right? Remove the H from what? From the alcohol. So after you identify, hey, this part is from the acid, if you only put a OH back to the C, you can get the, we call parent acid for this ester. And the same, you put an H back to the O, you can get the parent alcohol for the ester. Does it make sense? If I ask you here, where do you think, which acid and alcohol do you think make this ester? You identify the ester bond, then what? put the OH back to the acid. This is what the parent acid should look like. Put the H back to the what? To the O. Of course, the R, you just copy. Then you should figure out what the parent alcohol was. Does it make sense, guys? Does it make sense? Okay, and this is very, very important. Okay, very, very important. Because it will help you, understand the hydrolysis of ester bond. The hydrolysis of an ester. This reaction. If you understand how to identify the parent alcohol and ester, you have zero problem of completing this reaction. The hydrolysis is basically the reverse reaction of ester formation. Okay, the reverse reaction of ester formation. Hydrolysis of an ester bond is basically you break the ester bond instead of forming the ester bond. Okay, break the ester bond instead of forming ester bond. So take a look what happened here. Again, after you see a molecule, you need to identify what? COOR is what? Ester. Is that right? Hydrolysis means we break the ester bond. Okay, break the ester bond, adding water back to the acid and alcohol. Break the bond first. Water again is H and OH. That's what we call hydrolysis because you're adding water. The OH is added to where? Take a look. To the acid, right? The H is added to where? Alcohol. To the alcohol. You get two molecules back. That's what we call hydrolysis. Basically, you're breaking down an alcohol. An ester. Does it make sense? And why we call reverse, okay, why we call the reverse reaction. Think about it. Last time we talked about this direction. What do we do? Remove the OH, remove the H, then what? Make the bond. That's called ester formation, right? We call it esterification. I mean, it doesn't matter. You remove these first, you make a bond. And take a look from this direction now. You break the bond first, then what? Adding the water elements back. Is that right? Adding the OH, again, the OH always added to where? The acid. H adds to where? Alcohol. To the alcohol. That's called what? Hydrolysis. Okay, hydrolysis. Why hydrolysis? The word hydrolysis came from what? You're adding water. You're breaking a bond and then adding water. That's called a hydrolysis. Does it make sense, guys? Okay, these reactions are actually, in reality, they are reversible. Okay, they are reversible. Okay, that means when you make an ester, at the same time the ester is going to reverse if the condition is under acidic condition. Okay, the reaction is actually reversible. Does it make sense, guys? Good? It depends on how we write the reaction. If you start with an ester and water, that means hydrolysis. If you start with these two, that means esterification. It depends on how they're given. Okay, now, if you understand, all of you, please try the hydrolysis. The top reaction, I give you the arrows already, show you how to do it. The bottom one, nothing. See if you can do them following the scheme of the previous slide. Okay, well, just shut here. Give you a couple of minutes, then I'll take a look, and then I'll put the reaction, the products on board, or I can go over one of them with you. Try to copy the structure first, and then work on them based on what we talked about in our previous slide. Good. See, I see some of you, a lot of you starting to click, and the reaction will make more and more sense now. And how do we work on these organic reactions? Okay, that's all we need for this class. Okay, we are not, in fact, okay, I always forgot to mention, we're not actually dealing with how really the reaction happened. We just want to figure out the transformation itself. Okay, how when we hydrolyze an ester bond, what are the products? That's all we need. The reaction doesn't really happen this way. Okay, there's a scheme of stepwise how an ester is hydrolyzed. We call mechanism. Okay, that's the topics in organic chemistry, in science major organic chemistry. In this class, we're not dealing with the stepwise what really happened. We want to figure out what is the transformation from A and B. What do we get? The products, and what are they? So that's only the basic stuff for the purpose of this class. Very good. Perfect. Yes, great. Anyone? Want to show me? Where is it?
So in our book, they're different, so I can print them.
Oh, yeah. I don't know. Yeah, maybe different. That is correct. And that is also right. Perfect. Yeah, those are from the previous slide, I think.
Yeah,
Yeah,
but we
those are
don't
from.
have those in our.
Yeah.
So,
Yeah, you can put it here. Actually, those two reactions, put it here because they're here. See that? Actually, put the reaction here on the bottom. Perfect. Great. The OH to that.
So you just putting it together to
The
see.
OH to that. Yes. Hold on. OH. Yes. Perfect. Okay, perfect.
it just looked funny.
Yes. Some, I forgot. All right. Okay, the first one, Charlotte. OCH3. Okay, first, again, you copy the structure. Okay, just exactly copy the structure. Like we said, you can see I put in dash. That means find and cleave what? Cleave the ester bond, right? Use your eraser, cleave the ester bond. This is the ester bond. But after you cleave the bond, that means these two atoms, the C and the O, originally they're bound together. You need to put something what? Back. Okay, that something is what? From water, the elements of water, H and what? OH. Okay, like we said, in ester hydrolysis, the OH is back to what? To the acid. And the H is back to what? To the alcohol. That's it. Okay, that's how we hydrolyze an ester bond. Again, if you hydrolyze an ester bond, you need to break the bond first. So OH back to the C, H back to what? Back to the O. Okay, the rest of them just copy. Don't lose anything. Just make sure you copy the structure first. Okay, the second reaction products are COOH, and okay, there are 3 carbons. 1, 2, 3. You only need to put 3 carbons. Okay, those are the products. You can put a plus, means those are the 2 products from hydrolysis. Okay, in tests and in quizzes, you need to provide both because they're both organic products. Sometimes I said you don't have to put water as a product, as a byproduct, because water is inorganic. Okay, but both of these are organic products. That means you have to put both, the correct structure both. Does it make sense, guys? Easy? All right, next, following this. Okay, following this. Like we mentioned, you can see that for ester hydrolysis, okay, usually it's under acidic condition. You can see the arrow we put here, okay, including the previous few slides. The arrow is what? Double. It means, again, the reaction of hydrolysis and ester formation are reversible. Okay, these two reactions. What is reversible? Refer means they're going backwards all the time. Okay, they're going backwards all the time. If you want to hydrolyze this ester, for example, the products, these two guys, under this condition, actually are going back to remake the ester. So we always ending with a huge mixture because you can never go completion because the products are going backwards. Okay, that's what reversible means. Okay, in order to solve the problem, if we really want to hydrolyze an ester completely without worrying about them going backwards, okay, we have a very important reaction, still hydrolysis, but a little bit different, called sabonification. Okay, called sabonification. What is sabonification? You only need to memorize this word, this reaction, sabonification, with a few words. That is hydrolysis under basic condition. It is hydrolysis, still hydrolysis. But take a look. These three words are the most important for defining for understanding what sabonification is. It is hydrolysis, but under what? Basic condition. Under basic condition means you have base in the reaction mixture. Okay, I have base in the reaction mixture. You have base in the reaction mixture. Okay, let's try this first without putting on the board if you guys can't understand this reaction. How do we get these two products? If not, I'll work on more on board. Think about it, guys. Sabonification means, again, hydrolysis under what? Basic condition. So let's first look back, hydrolysis. When we have hydrolysis, what do we get? What do we get in hydrolysis? Acid and what? Alcohol. Is that right? This is what we get from hydrolysis. Acid and what? Alcohol. Good. Now think about it. If I add base to the whole mixture, these two guys from hydrolysis, one of them will further react with that base. Which one? The acid will react with the base. If you guys remember the reaction, let's turn back. Okay, we have seen this reaction here. You guys all practice this reaction. What is it? When you have an acid at the base, take a look. What do you get? The COOH will be converted to what? COO minus and what? Sodium plus. Is that right? You guys see that? Acid with a base, what do we get? COOH becomes what? COO minus and what? K plus. You guys see that? So that means for hydrolysis under basic condition, again here is hydrolysis, you get what? Acid and alcohol. But if under basic condition, the acid COOH will be further converted to what? COO minus and Na plus, a salt of this carboxylic acid. Alcohol doesn't change. Alcohol doesn't react with the base. With a base, the acid will be further converted to what? To a salt. So sabonification is still hydrolysis. You still need to break this bond. You still need to put OH and H back. That's the same. But you have one extra step. The acid will eventually become what? Salt. Does it make sense, guys? Good? It makes sense? Try it. If not, I'll work on the board with you guys. Try this reaction. Okay, if not, again, I'll work on board with you to show all of you the steps. Okay, this is saponification. Again, how do we recognize this is saponification reaction? You add what? Base and water. That means hydrolysis under what? Basic condition. Okay, try to see if you can get the product. Done?
Yep.
Beautiful. Great job. Very good. I'm so glad, guys, you clicked now. It's make more sense throughout these reactions. Right? H cap. Hydrogen is capital. Okay. I know those are small stuff, but you have taken chemistry now. People will laugh at me who taught you chemistry. The symbol for elements are all. The first one, this is the correct product. The alcohol you have to copy. CH3OH is the alcohol. CH3OH. All right, guys. Okay, let me put on board again. You're doing great. Okay, like a real life or practice your homework. I recommend you to do this reaction 2 steps. Unless you're super comfortable, you can write it down directly, whatever the products are. That's fine too, but I recommend you to do this 2 steps. Like we said, saponification is still what? Hydrolysis under basic conditions. So the first step is the same, what? Hydrolysis. You need to break the ester bond. You need to find where the ester bond is. That's why we keep saying, when you see a molecule, if it is an ester, you need to say, where is the ester bond? This is the ester bond. Break the ester bond. Then what? Do the hydrolysis. Add what? H and OH. OH back to the acid. H back to the alcohol. Okay, alcohol. You don't have to. You can write the whole structure prettier, okay, later, or you can just leave it like that. Okay, this is the acid. This is the alcohol. These two are what? Hydrolysis products. But if the condition has base in it, the acid will what? React with the base. Okay, the acid will react with the base. We practiced this before. When you see an acid-base reaction, you mark what? The charge. The O is O minus, H is AH plus. Na is Na plus, OH is OH negative. So these two, the acid-base reaction is simply what? The H and what? OH reaction. The H plus and OH minus reacting give what? To give water. So that's why with the base presence, your products are O minus and what? N plus. Okay, these are the products. Again, you're doing 2 steps. First is what? Hydrolysis. Then take a look at the condition. Okay, take a look at the condition. If it is under basic condition, the acid won't be acid. The acid will be further converted to what? To a salt. Okay, to a salt. And because of that, because your acid was no longer an acid, is converted to a salt, the reaction can go what? To completion. It would never go reversible because these two don't react back to an ester anymore. Okay, that's why ester hydrolysis under basic conditions, saponification reaction, is complete. Okay, complete. Okay, we will see this reaction again in chapter 8. Okay, in chapter 8. This is the reaction used in industry to make soap. It's a very, like an old reaction. People discovered that we haven't been using soap for a long time, before even they're commercialized. Okay, that's how soap is made. Okay, by treating fat and oil with base. We'll see that in chapter 8. Okay, so that's most of this chapter. The ester, the hydrolysis, and this bonification. Okay, one last topic. Okay, one last topic we're going to study is the ester of some inorganic acids. Okay, the reason we study this topic because you will see this bond, this type of structures a lot when we study biochemistry in carbohydrates and more in nucleic acids. Okay, that's why we study this topic in chapter 5. Chapter 5. Normally we don't deal with inorganic acids, but we will see this type of structure a lot in the next few chapters of biochemistry. Okay. The ester bond can be formed between carboxylic acid and ester. We have seen many examples during the first part of this lecture. But the ester bond can also be formed between inorganic acid and alcohols as well. And those inorganic acids include sulfuric acid, nitric acid, and phosphoric acid. We won't study them all, but we will take a look at the ester bond between phosphoric acid and alcohol, because that's most important in biochemistry. Okay, in biochemistry. Now, before we study this reaction, I'll put the structure of these two types of acid on board. You take a comparison, you will have a better understanding. We know carboxylic acid, the functional group is what? CO what? OH. This is one of the carboxylic acid. Of course, this is acetic acid. Let's put the structure of phosphoric acid on board. Okay, phosphoric acid, usually people put molecular formula like this, H3PO4. Okay, H3PO, that's phosphoric acid. But the structure of phosphoric acid is like this. PO, OH. The only difference is you have 3 OHs on the phosphorus. But take a look. The functional group between a carboxylic acid and phosphoric acid are actually very what? Similar. Do you see that? CO what? OH. PO and what? OH. They're similar in many ways. Okay, for example, this hydrogen in water will do what? Will ionize to become a what? H3O+. Do you guys remember that reaction in water? Hydrogen will be taken by water to give what? H3O+. The same, phosphoric acid can do the same thing. We didn't study that because phosphoric acid is not one of an organic acid. That's why we don't study that. But because they're similar, phosphoric acid can also make ester bond with an alcohol. Okay, here is the reaction. Take a look. Do you see something very similar? Phosphoric acid is what? POOH. If I remove the OH from the acid, remove the H from the alcohol, make a bond with the P and O. So we get a functional group POOR. Do you see that? Is that same as we just studied in the very beginning of today's lecture? Remove the OH from the acid, the H from the O. Make a bond between the P and the O. Again, the O is from what? From the alcohol. We have the bond POOR. This PO single bond is what? Ester bond. We just give it a new name, a phosphate ester, because it's from phosphoric acid. Okay, phosphate ester. Do you guys see that? The same as what? The same as here. The same as here. Do you guys see that? Remove the OH from the acid, H from the alcohol. Make a bond between the C and what? And O. You get what? CO what? OR. The same there. Sorry. Oops. Remove the OH from the acid, H from the alcohol. Make a bond between this P and what? O. You get PO. OR. We call this ester bond again phosphate ester. Okay, phosphate ester. This is the same thing, except C comes what? Becomes P. Another major difference here is we know carboxylic acid, take a look, COOH. On the C, there's only what? One OH. That's why you can only make one ester bond with carboxylic acid. There's never gonna be two because carbon only have what? 4 bonds. Okay, there's another one is with carbon. So you technically have only chances of one OH. But phosphoric acid, because it's inorganic acid, it doesn't have carbon or anything on it. On the phosphorus, you actually has what? 3 OHs. That means you can do this reaction technically what? 3 times. This is the first time. You got an ester called what? POOH. This ester is called a monoester because you only make what? One ester bond with one alcohol. And you can repeat that reaction second time, third time with those 2 H. Of course, you need 2 more alcohols. So you can get a diester, and you can also get a what? Triester. And those alcohols doesn't have to be the same. It can be different alcohols. Okay, that's why I put R prime, R prime prime, R prime prime. These can be different alcohols. Okay, phosphate esters, especially monoester and diester, are extremely common in our biological system. We will see that in chapter 7. Okay, I'll give you one example right away of phosphate monoester. And in chapter 11, when we study nucleic acids, DNA and RNAs, you will find out our DNA molecule is built on phosphate diester bond. Okay, our DNA molecules are linked by phosphoric acid. Okay, that's how it works. In this nature, in the planet Earth, all DNAs are made by phosphate bond. Okay, I've heard some in the earlier days, they found a bacteria down in the ocean, their DNAs are not by phosphorus. Maybe an 80, or maybe something we never saw before, or maybe an 80. So far on Earth, all living things, their DNAs are linked by this bond, phosphate diester bond. Okay? Finally, take a look at the example of some phosphate linkage. Okay, phosphate linkage. And by the way, this is in phosphate monoester again, PO what? OR, see that? And the other 2 are OH, that's what we call monoester. Okay, mono means what? Only one ester bond. Under physiological condition, okay, means in our blood system, for example, those 2 OHs, okay, those 2 OHs are ionized. Okay, normally people write phosphate monoester, those 2 OH are what? In what? O minus. Okay, they're both in O minus. Where the H go? The H are in the blood with other ions. Okay, we have a lot of buffering system in our body. So under physiological conditions, phosphate or phosphoric acid exists in this form. POO what? Minus. Okay, minus. And this structure is a glucose 6-phosphate. Okay, glucose 6-phosphate. What is this molecule? This molecule is basically the first step if you take some carb food. the first step, glucose need to be metabolized. You have to convert it to a glucose 6-phosphate first. No matter who you are, no matter you eat bread, noodle, rice, after your starch gets hydrolyzed, become glucose. If you want to utilize glucose to build your carbon, your synthesite to provide you energy, glucose must put a phosphate on this OH, on this carbon, in order for be further metabolized. Okay, my question for you, can you guys recognize that phosphate ester bond? Where is it? Which bond is the phosphate ester bond? The P and what? The O bond. Here is the phosphate ester bond. You can see that? P-O what? O-R. You see that? This single bond here is the phosphate ester bond. Of course, it's the monoester because these two O are what? O minus. You see that? Right? So that's all for chapter 5. Okay, let me know if you have any questions